morning, everyone. Thank you for the introduction, Claude. So, since I last gave my bio, or that was my latest bio to Claude last night, so I used to be a principal consultant for water-based systems engineering, and that's basically what I've been doing for most of my professional career anyway. Recently I became the offering manager for Rhapsody and model manager, okay, for the IBM model-based systems engineering solutions. But a little bit about a story about how I got into this, and it's going to cover some of the things that why some of the approaches were taken. So Claude mentioned I am co-chair of the Unified Architecture Framework. This is a framework that sort of we genericized from DODAF and MODAF. But while I was doing that work, I was asked to help the IIC with this Industrial Internet Reference Architecture, and that's basically how I got involved with it. So there is some similarities between how you're using the Industrial Internet Reference Architecture and how they use with Unified Architecture Framework. And a lot of this came about thoughts around, initially when we started doing this, the IE started doing this, IoT was a big buzzword. But the problem was, no one was really doing systems engineering or any engineering around it. They weren't thinking of it as architecture, it was all slapped together. And that's the thought you've got to bear in mind about where this is coming from. So, what is the Industrial Internet Consortium? I don't know whether Claude introduced it, but basically a sister organisation to OMG. It has a number of crossovers in the membership, and between OMG and also IIC, and IBM is one of those crossovers. They were one of the founding members of IIC. The objective of the IIC was really around understanding what IoT could do in industrial use cases. And the intent was to start building up these industrial strength use cases and test beds to see how they could work and to actually develop these architectures so that people could use them together. And as a result, it's a combination of industry and tool vendors. IBM has worked on, I think it's 2 or 3 test beds, but there's a lot of people involved with this. It's running around 220 members now, which I just checked, so it hasn't changed too much from where we were before. But the idea is to bring together this operational technology and also the information technology together, and that's basically what the graphic on the right-hand side is doing. It's just bringing it, it's about understanding how we can use the information that we're getting from industrial use cases and using them to make our operational side better, more efficient. And when we're doing this, there are a whole bunch of unique set of challenges that we need to deal with. So part of it is around business development. One of the issues that we constantly see with IoT is the IoT-enabled chocolate teapot. Okay, this is the idea of a chocolate teapot is if you put hot water in it, it just disintegrates. Okay? There's a lot of cases like that. Why do people really need IoT added to anything? Okay, so you've got to have a reason to do it, there has to be value. Then you've got to think about the engineering that goes into it. How is it meant to work, what's the context, how it actually ends up being used, and how do you make sure that it doesn't damage or have emergent properties that actually damage something else and have effects which you're not aware of that could be actually catastrophic. Then it comes down to implementation. I think the landscape of the IoT has got a little bit less varied now than when I first started working on this. But 2 or 3 years ago, it was like the Wild West. People were coming up with all sorts of things and ideas, and really there needs to be a separation between the functionality that you actually want to implement, or you actually want to have, as to how it's being implemented. And parts of the way the framework works is it gives you this separation between the what you want to do to the how you want to do it. And where this landscape of technology is changing rapidly, this is very effective. And then the biggest, or one of the biggest things that has come out is about security. Okay, we're not just dealing with closed systems. They're very open systems with a lot of information that's being floated around, a lot of open ports on various devices for people to hack into. So, the IIRA, well, the Industrial Internet Reference Architecture is only one of a number of frameworks that exist within the IIC. One that I'm probably most interested in, though, because I ended up working on it. But there's also the Business Strategy Innovation Framework. The idea behind this is it looks at the high-level business aspects of the organisation involved in this development, and also a capability model to say how well you're doing it. There's also a connectivity framework, which is a set of ideas about how you're starting to join the various IoT bits together. And then also the Industrial Internet Security Framework, which is something else which we have an interest in, partly through the work that I do with UAF, but also from the practical aspects of actually applying the IoT to itself. The bits that I'm mainly going to be focusing on in this talk is really around the reference architecture and the Industrial Internet Security Framework. And one of the other key things that comes from this, and I think it goes back to what Claude was saying, is some of the ideas that we've had coming out of IIC. We've actually tried to implement the standards within OMG and to tie them back to those practical use cases and try to work with them. And that's partly where the idea of what we did with the Unified Architecture Framework came from. So, in terms of what the IIC, or the Industrial Internet Reference Architecture, talks about, it has a number of different layers to it. The top layer is the business viewpoint. It's really about how or why do you want to do something? What's your motivation, okay, to actually developing this particular application? What are you trying to do? And it forces you to think about what the users are, okay, and who's benefiting from it, because a lot of what IoT is about it's monetizing information in some way or other, okay? So you really need to understand that, and that really comes from taking a bit of an enterprise architecture approach, and because of the nature of what we're doing with industrial internet, it's really around taking systems to systems architecture as well. So we don't just think of single standalone sole bits of equipment, we're really looking at it across whole systems to systems. And then once you've worked out what you actually want to achieve, we can then start to look at it from understand a little bit more depth. So we have this usage viewpoint, which is really looking at it from a functional perspective, usage scenarios, and it breaks the behaviours that you want to achieve down into activities. And then the next layer down, which is the usage, that's basically what the usage and functional viewpoint do. The next layer down, or the final layer, is implementation. Okay? And the idea behind this is it sets up the architecture. How are you actually starting to connect your endpoint sensors to your decision-making processes, and what are you going to do as a result of it? And the way that we develop this, because of, I come from an MBSE background, so we tend to be very formal in what we're trying to do, but the IIC wasn't particularly ready to do this at that particular time. What I was doing was a bit too heavyweight for them. So we ended up simplifying it, and it got turned into a bunch of checklists about how you should be doing this stuff. But we can make it more formal, which is what I'm going to talk about later. The other thing is there are a number of cross-cutting concerns. I think in the booklets that we have here and at the back, there is a more up-to-date version of this diagram, where you're looking at various life cycle processes and various domains that it goes across. But one of those areas that you need to be worried about is security. And that pretty much starts off right from the very beginning. Okay? Like safety, security needs to be designed in. It shouldn't be added as an afterthought. Okay? And as I said, security is just one of those layers. The end result is by taking this framework, we'll go a little bit over the simplified meta model in a minute, we can map it to the work that we've been doing with the unified architecture framework. Okay? And we can start to formalise it, and we can start to build architectures and start to do engineering properly. So, in terms of the various viewpoints, I don't know whether you can see that, it probably might need to be made a bit bigger, but the idea behind the business viewpoint, it starts to bring out, identify the key objectives that you need to do and the key capabilities. So the key objectives are over there. Okay, what are you trying to do, and then driving it onto the key capabilities that you're trying to implement. Okay, and the important thing here is you need to have measures. It's no good saying we want to connect this to this for this reason without having some way to evaluate what you're doing. Okay, because you need to measure what you end up producing at the end of it to make sure it realises it. And then this ties down to the aspects. That's a bit better, I think. From here, oh, that doesn't work. Okay. From here, we then take it down to the various roles. So we're starting to understand how those capabilities are realised, break them out functionally into activities, understand who's reacting with them, various parties, and then we've got the sub-roles and how they break down as well into various other activities. And this is about separation of the what you want to do from the how. Okay? Because what happens is those activities get broken down a little bit further into functions. Okay? And we have traceability now. And one of the key parts of this is once you start to change things, how do you know what's being affected? Okay? So if you start to change your measures, that may affect some of your activities and your functions or your non-functional requirements. If you start to change your capabilities, that will almost certainly change what things are happening there. And when you get down to implementation, you have a even bigger effect, okay? Because you now got to tie those functions to implementation, and you're looking at maybe some type of software technology which is doing analytics, some sort of services, managing security, doing some form of control, and what's it all sitting on, okay? We all talk about the cloud, but the cloud is a big bit of hardware that sits somewhere. It has to be developed, and it has to exist, okay? So you're going from something which could be very physical, that exists in one place, to something that, or very small and physical that exists in one place, to something that is very large and sits on a server maybe 200, 300 or 1,000 miles away. Okay? And it may be gathering and working with all that information. So once you start changing this and you start changing those measures are really functional constraints. They're constraints in your architecture, non-functional requirements. And they control how this is implemented. And that's the reason why you have to separate the functional aspects, the how, or the what, from the how. Okay? And that's why it's really important when you look at the next stages of, as the technology changes, that's going to slot in on that layer and you can start to update it a lot easier. So one of the recognitions that has come over the past few years is that there is a lot of similarity between IoT and systems of systems. Okay? And the idea behind this, the way that we do this, there's a paper by Meyer. This is the best known paper around. It basically identifies systems as having these 5 traits. So operational independence. Okay? This means something that can act by itself, independent of other things. So think autonomous vehicles, for instance, and how they might work. Or even smart meters, or even smart homes. They all act individually to each other. Okay? They have managerial independence, so they exist in their own right. People work with them separately. Evolutionary development. So one of my friends, so I know this is a smart energy, or this is about an energy focus, so one of my friends, his evolutionary development of the IoT is far, far ahead of mine. We haven't got any IoT developed devices in our house apart from a smart meter, which is not very smart. Okay, we'll talk about this in a minute. The next thing, I think he's got Nest. He's got Nest heaters, and he's got Nest controlled lights, and all sorts of things. Okay, but because of even the nature of what he's got, okay, he's got issues because, and has security issues because people can apparently hack into his power usage, and they can see when he's in the house or not, depending upon how it's being used. So he's basically got to heat his house as if he was there if he goes out, otherwise they can see that he's not there. And this isn't just as simple as turning on your light to anything. So there's a whole bunch of things that actually come out of this, and that's where we get down to emergent behaviour. Okay? It has effects that we really don't understand, and there's an example that we're going to talk about in a minute. Geographic distribution. These systems cover wide areas. And ultimately, we also come down to this huge network of bits connected together. Problem is, it is huge. Okay? It's very easy and open for attack. There are certain systems which are hostile, which can actually find these weaknesses, and they can identify them, and they will go into them. And one of the big things, we do have a big security work group within OMG as well that actually tries to identify these issues and works with them to try and solve them. Yeah, so these are just a couple of means of ways that this can be affected. So when I first started doing this, a lot of this presentation came out of some ideas that I had probably about 5 years ago. And we started off with the idea of the connected washing machine. And partly the idea behind this is it so much depends upon the perspective of who's implementing the IoT and what they're doing. Okay, what are their objectives? So the idea of the connected washing machine was to reduce energy costs by connecting your washing machine to the internet and saying, okay, find me the cheapest rate for my electricity. Okay? So we can turn it on automatically whenever we want to go through its cycle. Okay? So that sounds great to start with. That's a brilliant idea. So we have our connected washing machine going to a smart meter. It's also using some power from the local power companies. Great. That can control it. The smart meter starts to work on when the cheapest rates are, and it goes, okay, we're going to turn you on now. That works. That works for small implementations. It'll work for maybe 100 houses. Yeah. Take a city like London or New York, which is 6 to 8 million people. Okay. The example I like is Seoul. Seoul as a city has 20 million people. So take one night, you've maybe got 3 or 4 million people suddenly start to put their washing machine on at the lowest rate at night. What is the effect of that? suddenly it's not just about the washing machine manufacturer trying to control the power usage. It's about the power companies not being able to get enough power, to produce enough power. They've then got to buy power from somewhere else. Okay? In the UK, we get a lot of our energy maybe from Russia and France, and that costs us a lot of money. So unless you get this balancing right, it doesn't quite work. But what it does lead you to do is to think about these big industrial, socio-economic effects. This is what we call emergent properties and emergent behaviour. So when you look at it in a more realistic way, you've got to think about millions of washing machines that may be connected. They need to be tied to the grid, but they also need to be tied to the white good companies, which then need to combine that information and then maybe have some sort of smart scheduling that can control how the washing machines are sequenced and work together. And all this is done so you can regulate the power that's coming from a power station or a set of power stations. Okay? And suddenly you've gone from what started out as being a very simple, nice idea as to being something which is really complicated. And this is why we need to think about it and why we started to take a systems engineering approach to this. So when we look at it from a systems-to-systems approach, the typical thing is to start off to understand the as-is and to-be. So we can integrate with legacy stuff. Okay? One of the great things that's going on in the UK at the moment is smart meters. What have they discovered? Basically, we've been going over that the past 3 years to get smart meters put into all the houses. The problem has been that they've come in, put them in, but then people change electricity provider. Do the smart meters actually send information to the new electricity provider? No. Okay? There's got to be there's 2 or 3 generations that they need to generate to actually be able to do that, so they've got a central way of actually communicating with it. And it's just like, yeah, okay. It scares me, the lack of engineering thought that's been put into some of this. So the way that we start to deal with this is to start looking at this capability-driven approach, very service-orientated, you're separating the what from the how. The service in this instance may not be a software service, but I call it a system service. But basically, the service allows you to map some functionality to different forms of implementation. It can be done in software, or it can be done lots of different ways. But that allocation of behaviour is really important. Okay? And because of the way that the IoT is, that doesn't necessarily have to be on the device. Okay? And it could be allocated in several different places. So what we've got there, I'm sorry about the faded graphic, I'm not quite sure what happened with that. But this is basically a small schematic that might show how a mobile phone interacts with a vehicle. Okay? And we've got an application called Bluemix, a platform called Bluemix, which allows you to tie all these things together. But what becomes interesting is that everywhere that you've got an interaction, okay, or a new piece of equipment, you've got an interface. Okay? And the key to, a lot of the key to systems engineering, a lot of the key to making this work, is making sure you have the correct interfaces that exist between everything. And they can be all sorts of different things, APIs, services, data, security. When we look at this, I think I can tell this is a fairly simple model. Because of the way the interfaces work, we identified at least 16 points of potential attack. And that's just through the nodes, how they communicate with each other. Sorry, going the wrong way. The other thing that we're finding with the IoT, you've got a blurring of the lines between functionality and engineering. So a lot of some of the stuff that we do is around management of assets and also management of operational management of the things that are being produced. So what we're finding is what's happening is the things that we are enabling on the right are feeding back information, not just to control them, so it's bi-directional, but that information is actually being fed back into the development process, into the engineering process, which is another way of working it. So this is how you can start to drive better energy management. You might be able to identify homes that are leaking energy, for instance, and be able to not just through wasting it, but just literally leaking it. From that, be able to generate more services for your business, for instance. But the engineering has to be embedded within the product to actually be able to do this, and it's really tying your engineering into your operations. The other thing that we find, if you go back to the example that we used with the washing machine, it really leads to this wider collaboration across the different players in the industry. Okay? So, for instance, in automotive, basically we've got if you're starting to do autonomous vehicles, the vehicle doesn't exist in its own right. It exists in concert with everything else that's going on around it. And when you look at this collaboration, you may be driving a BMW or a Mercedes or a Ford, but how do you see 4 or 5 vehicles down the road? You've got to have some sort of communication with those other vehicles in front. That's fine if you're all a Mercedes and you're driving a trained Mercedes. But you've got to be able to communicate with the Ford, with the Chrysler, with whatever it is up ahead, maybe to see some of this. So again, you've got to start using this. You need to be much more collaborative. And this is also comes out in the white goods example. So, what does this mean in terms of the Industrial Internet Security Framework? For one thing, all that communication needs to be tied together. We need to make sure that it's safe. And when we look at security, you're looking at how you combine, you can combine threats and how you manage those threats through systems, organisation, time. And it leads to this thing called trustworthiness. How trustworthy is your system, for instance? And really what security is around managing that trustworthiness across the system and systems as well. Okay? And what we have for that, there's a framework. It has these operational systems that are managed by owners and operators that need to understand what they're doing. There's a lot of work goes on with systems integrators. Okay, how are they relating information or moving information between them, and actually controlling the interfaces that go on even at that level. And then finally you get down to the different bits of hardware that actually implement all this and how it's being managed. All this needs to be ensured, it needs to be trustworthy. So we've got hardware, software on there and services as examples. So the UAF, work that I've been doing for about the last 10 years within OMG, but we're at our 1.2, I think, or 1.1 for UAF we're currently working on. It's our 3rd major release. The idea is that it gives us these layers, so we can look at strategic and operational stuff, look at how services work, define personnel and resources that actually implement stuff. One of the big additions that we had was security. This was driven by a lot of, DINDAF, which is Canadian Defence, but it's also been working with NIST on this. And then how we actually implement all this stuff through projects and how it all maps to standards, because traceability is key. The origin of this came from military standards or frameworks like DODAF and MODAF, but the other big change that we did in UAF was to genericise it, to get rid of all the military terminology. So it actually makes it much more commercial and available for commercial use. The key thing about it, though, is we can still use it for other means. We have a meta model there that we can lay a skin over and we can map it to lots of other different frameworks. One of them being the Industrial Internet Reference Architecture. So we can start to do proper engineering, systems and systems engineering on IoT systems. So the rows, I think we're actually calling these domains now. We're calling them but they're not exactly levels of abstraction because they're bigger than that. But we call these domains. The columns are model kinds. They relate to standard means of representing model-based or parts or aspects of the system, different means, and normally it's mapped to SysML and UML. Okay, so you end up with things like block definition diagrams, internal block diagrams. You have state machines, you have activities, capturing behaviour. You have measurements which are capturing parameters, information, then constraints, and then some way to progress through them, i.e. the roadmap, how you're developing your capabilities over time. So from the perspective of the IIC, we map the business view to the strategic part, the usage and functional view to operational. It also ties into some of the functional view, ties it into services. And this is really tying it into how we're going to disrupt the business. Identifying analytics and thinking of systems as a service. And then implementation. Although this talks about personnel, the idea is really to talk about resources and to talk about things that can implement the services and the operational aspects. And then for a cross-cutting view, we also had that cybersecurity analysis. Okay? So that's how it maps onto the IIC. When we look at it from the security framework, as we said, security is cross-cutting. So even though it's a layer, in reality, it's a vertical. We just need a way to represent the things in this particular grid. Okay? And the idea is that at the business view, we're mapping our top-level security concerns, its capabilities, identifying them as risks and how we mitigate them. Okay, so we're looking at how we can define functions and services that mitigate against the security risks and the issue and trustworthy issues that we have, and then how they actually get implemented on a particular form of implementation. Okay, and that drives down to our personnel and resources, or personnel and resources. As I said, the whole idea behind this, I come from a safety critical background, and the first thing you're taught when you do that is safety is designed in. Okay, you don't do it as an afterthought, and it should be exactly the same with trustworthiness and security. It needs to be designed in up front and thought about up front, and not just added on. So, I'm sorry I haven't got a power example, but I think I've already given you a bit of an idea about how this might work. I'll try and turn this into an analogous to power, but one of the ways that we worked on this was to look at applying the IIC or the IIRA to Unified Architecture Framework, and we ended up using autonomous transport management. And when we first started doing this, and I don't know whether this is going to work, but there was ideas around management of autonomous vehicles, and what it came down to, well, people were talking about the autonomous vehicles being controlled by the cloud. Okay? Don't know what that actually says because I can't see it. Sorry, I don't think that link's working. It's doing some sort of connection. But I found there was a television program in the UK, and it was looking at London over 24 hours. And part of that, they put a GPS system in I think it was like nearly 400 taxis, or 380 taxis. And from that, they looked at how they worked in London, and they did these light traces. And it gets fascinating how much energy is produced by these taxis and where they go. And when you look at the ideas that they had about managing that from the cloud, it wasn't just people thinking that they could do the autonomous driving, it was controlled by the cloud. I know we've got things like Waze now, and we've got GPS that actually takes into this account. When you look at how cognitive and smart systems work with this, it should be about directing. Okay? It's about giving strategy and direction to the things that you're talking to. And this is part of the difference of how things work. Okay? So you end up with a local control and you have a direction control. This is sitting on the cloud, this is sitting on your device, or it's sitting at the edge. And it's how these communicate and what information is passing between them. But where it comes together, so we ended up identifying a number of business capabilities, and a lot of this ended up being around managing traffic around the city to enable or to save time and to improve safety. I think the actual use case that we ended up working on was something like smart speed monitoring. Okay? So instead of having a static speed zones like 40 mile an hour, 50 mile an hour, when it got busy or got too clogged, it would actually control the vehicle, not just having something that goes up on the overhead on a motorway, actually control the vehicle to constrain that speed in the vehicle. So I identified the business capabilities, and from there we start off with usage, which is a set of activities which understand it's about the how, what we needed to do, and then we tie it into a deeper level of behaviour, and then we can start to map that to implementation structure. And then, because of the tools we use, so in this instance where we're using Rhapsody, we were actually doing simulation with it to ensure that it was actually working in the way that we expected. We're getting validation of it. And Rhapsody is quite clever. It's not just around doing the systems design. We also generate the software, and we can also tie in our outputs from this into the cloud and actually generate the code that sits on the vehicles or sits on the cloud or whatever we want to do with it. So it's very wide area. And over all of this, you end up with security analysis. In terms of implementation, we can take that systems-to-systems model, capture it as a design, tie it into Bluemix, which is our platform for IoT. We can implement something called MQTT, which is a messaging service, or as DDS, as Claude was talking about. And that can talk to the device implementation model, or even the thing that sits actually on the IoT itself, or on the vehicle. And we end up with a number of different tools which support this, from requirements management on the left-hand side, DAWs, DNG, Rhapsody to do a lot of the solution architecture and the development of components in the vehicle, tying it into things like Node-RED. People come across Node-RED. Okay, so that allows us to do behavior on the cloud, and capture cloud logic and the logic flow, and then tie it into our analytics on the right-hand side, things like SPSS, and there's probably Watson up there as well. Can't remember what the other hexagon is. Various things around IP management, or API management, and also about the IQP, about how the information is being passed. And it really ties in simulation to the DevOps, change management, and quality management, because all of this thing needs to be managed ultimately. Okay? It's not just a case of hacking together a simple device that you can put on there. It works for hobbyists. It doesn't work very well when you try that in the real world for anything of scale. And this is really the idea behind this, is to be able to develop solutions at scale. So just give you a quick recap. So really introduced the IIRA as a fairly simple framework, a simplified framework which actually captures the business viewpoint, functional and usage, and implementation. We showed how the Industrial Internet Security Framework goes across this, and how both of those really map onto the Unified Architecture Framework. And from this, we've looked at how IoT systems and even IIoT systems are really an extension of what we call systems to systems engineering, and the sorts of things we need to look at to actually manage how we develop those systems, and the problems that can come if we don't actually start to think about them and don't start to think about engineering straight up. Because of the background I have, we've taken a very model-driven approach to this based upon the Industrial Internet Reference Architecture implemented in UAF, and we use that to derive and understand a pretty complex IoT solution. And just give a very, very brief overview about how that might be implemented. So, thank you. Any questions? I think we're on time. A minute or so.
Right on time.
Yeah.
Questions for Graham? We have scheduled. Yep. Oh, there's one back up. Can either Graham repeat the question, or I'll try to get a microphone back there.
Yeah. Hi, Neil Strawler from Navigate Research. I'm curious if you could look ahead 10 years to what you think will happen with IoT, because you've been at this a while and seen some change. What do you see in 10 years?
I see a lot more regulation, a lot more understanding about where it's going. I can see there's the amount of information that we're dealing with is huge. It's already huge. It's going to get even bigger. There's going to be a lot more around smart analytics and understanding. Being able to use the information and be able to filter the information to be useful. At the moment, we're overwhelmed with information and we don't know how to use it. So I think there's going to be a lot of work in that area.